Welcome to the APL quest. See APL Wiki for details. Today's quest is the 9th from the 2016 round of the APL problem solving competition. We are taking a text in and we're going to split it, but there's a catch. We're splitting it on not just one delimiter, but on any of a set of delimiters. Let's start by having a sample text. Right, so what's going on here is that we have two different types of delimiters. We have both comma and semicolon. And we also have consecutive delimiters, which we must respect. So we have to have an empty segment coming out here. That means as left argument, we're going to have comma and semicolon. And so these are our two arguments. And APL has these infix functions, user-defined functions. This is a lambda type function known as a defin. And in here, the left argument is denoted alpha as the leftmost letter in the Greek alphabet. And the rightmost letter is then omega, and that denotes the right argument. So we can see this just puts them next to each other. And what we want to do here is first identify where we have delimiters in our text. So we can use membership for that, and that vectorizes. So we're looking at every element of the right argument to see if it's equal to any element of the left argument. That gives us a Boolean mask, and this Boolean mask indicates where we're going to start our segments. And we can see the two ones here after 5 characters corresponds to the 2 commas over here. However, there's a problem. We could start splitting here. So if we use this partition function, then using this mask as left argument and using the text as right argument, then we lose the hello, because it begins a partition every time there is a 1. We need to start off with a partition right from the beginning. So we need to insert a delimiter at the very beginning of our text first. Before we do that, I just want to go my crusade against parentheses. I really don't like using parentheses for ordering execution. And the problem here is that APL's functions are all they all have long right scope. So everything towards the right of a function is the right argument, and what's immediately to the left is the left argument. And so because we have a complex left argument that's a whole expression to this partitioning function, then we need to parenthesize it. If only we had a function that was exactly like partition, but with swapped arguments, then we wouldn't have this problem, because the right argument is not a complex expression, it's just a single array value. And we don't have that kind of function, but we do have a modifier, or a monetic operator, we call it in APL terms, which goes in the immediate right of a function and then modifies that function to have swapped arguments. So now I can take the omega on the left and the omega member of alpha on the right, and we get the same effect as before. Okay, so far so good, but we still have this problem that we need a delimiter at the front. So there should be an extra delimiter. Any one of them, of course, will do, and that will solve our problem. So how can we do that? Well, we can substitute the omega for a variable that we create. So let's create it first, and we use diamond to separate statements in APL because diamonds are unbreakable. So this should be the normal omega, but we want to prepend a delimiter. So we can use the first function, that's this one, applied on alpha. That gives us just one of them. Of course, any one of them would be good, but there's always a first one. And if we concatenate, then that's going to put it at the end. But if we swap the arguments, then we put it on the front. So This gives us all the, oh, I need to go and remove this comma here that I inserted. This gives us all the segments that we want, but they all have the delimiter included, so we need to drop one from each. So this is again, a modifier, which is like a map that modifies the drop function, which otherwise would just drop one element. So this drops one element from each. And that solves our problem. However, we can write this a little more in a little bit more compact way. We can combine these two statements. If we had t at the very end of this expression, then we could just do a run on the expression because this has t as the final result. And we can do that because by swapping the membership here. This is t member of alpha, so we can say the membership swapped with t on the right. So this will still give the same result. But now that we have an expression over here that has t on the far right, and we have an expression here that has t on the far left, then we can just move it over to here. We still need the assignment because we're going to use t later, but this allows us to write this as a single expression like this. We could also give it, of course, a name. And then we can write like this. Or we could choose to split on vowels. Thank you for watching.